Imagine, just for a second, a microscopic synthetic molecule entering your bloodstream, slipping right past the blood-brain barrier and essentially taking your brain's emotional center hostage. I mean, it literally overrides your natural chemical boundaries, forcing this massive, totally unnatural release of your brain's most powerful feel-good neurotransmitters. Welcome to this explainer, where we're going to dive deep into exactly how MDMA hijacks your brain. We'll be looking at the incredible heights of its peak effects, the frankly devastating biological toll it takes on your nervous system, and why this highly controversial molecule is sitting right at the very center of modern psychiatric research. Let's get into it.
So, we really have to ask ourselves, what actually happens when a chemical rewires your brain's emotional center? Well, to answer that, we're going to take a bit of a chronological journey. We'll start at the exact moment of cellular invasion, then we'll explore the peak physiological and psychological effects, and finally, we'll aggressively examine the inevitable come-down and the long-term neurobiological price your brain ends up paying. It's a fascinating story, really. It's about a drug that forces extreme empathy but leaves this incredible physiological debt in its wake.
Section 1. The Great Brain Hijack, a Cellular Invasion.
Okay, let's dive right in. To truly understand the power of MDMA, we can't just look at behavior. We have to zoom way in down to the cellular level. Let's start with the basic hardware. What you're looking at here is the anatomy of a typical neuron. Your brain connects its different regions using these incredible nerve cells. Up at the top, you've got the cell body, and those branch-like structures called dendrites. Their job is to receive chemical information. Now, when the cell gets excited, it generates this large electrical impulse that travels all the way down that long trunk, the axon, until it reaches the bottom area. That's called the terminal. And this terminal, that is where the magic happens. It's exactly where MDMA stages its attack.
Now let's look specifically at a serotonin neuron terminal. See those little glowing spheres inside the terminal? Those are called vesicles. You can kind of think of them like tiny protective storage vaults. Under totally normal circumstances, the neurotransmitter serotonin is safely stored inside these vesicles, just waiting for an electrical signal to command its release. But when MDMA enters the picture, it specifically targets this delicate storage and release system, and it completely disrupts the natural order.
The hijack actually happens in 3 precise, honestly devastatingly effective steps. First up, MDMA reverses the function of something called SERT. That's the serotonin transporter. Normally, SERT's job is to act like a vacuum, sucking up extra serotonin from outside the cell and bringing it back inside. But MDMA flips the vacuum in reverse. It actively pumps serotonin out of the cell. Second, MDMA attacks those storage vaults we just talked about by binding to VMAT2 proteins. This forces the vesicles to dump all their stored serotonin right out into the cell's cytoplasm. And third, it partially inhibits MAOA enzymes. These guys are the cleanup crew that usually breaks down excess serotonin. So think about it. The storage vaults are completely emptied, the cleanup crew is tied up, and the vacuum is stuck in reverse. It's a total cellular takeover.
Section 2. Flooding the synapses, the peak experience.
So with the cellular gates forced wide open, we move on to the macroscopic physiological effects. What does this look like? Well, in the immediate aftermath of that 3-step hijack, because those transporters are working in reverse, a massive, unnatural flood of neurotransmitters just spills out into the synaptic space, that gap between neurons. And it's not just serotonin. MDMA also forces these huge surges of dopamine, which drives euphoria and motivation, and norepinephrine, which completely jacks up your heart rate, your blood pressure, and your energy levels. The receptors on the neighboring neurons are literally overwhelmed by this chemical tsunami, and that is exactly what creates the intense high associated with the drug.
But here's the thing. The monoamines are really only part of the story. Clinical studies with healthy users have shown that MDMA also triggers a massive release of oxytocin, which you've probably heard called the love hormone. In fact, plasma oxytocin levels hit a staggering peak of around 83.7 picograms per milliliter, roughly 90 to 120 minutes after taking MDMA. Just to put that into perspective, it's only about 18.6 after taking a placebo. That is a huge jump. This intense chemical surge in oxytocin is exactly what drives those profound feelings of empathy, extreme sociability, and that deep desire for interpersonal closeness that makes the drug so famous.
And this brilliantly illustrates why modern medicine is so incredibly interested in this molecule. Take a look at this comparison. A normal amygdala, especially in someone dealing with trauma or anxiety, is hyperreactive. It's constantly scanning for threats and triggering fear. But under the influence of MDMA, neuroimaging shows that amygdala activity is significantly dampened. At the same time, cognitive control in the prefrontal cortex actually remains active. So MDMA doesn't just sedate you, it rebalances your emotional circuits. It lowers the fear response while keeping you fully, consciously engaged. This unique state is exactly why researchers believe it holds such massive potential for processing traumatic memories in PTSD psychotherapy. It's a real game changer.
Section 3. The inevitable come down. The Tuesday blues.
However, you just cannot force the brain to dump its entire supply of neurotransmitters without paying a severe biological price. So let's talk about that physiological debt. I want you to let this shocking statistic sink in for a second. 80 to 90%. Yeah, animal studies suggest that a single intense session with MDMA can deplete up to 80 to 90% of your available serotonin stores. Think of your neurotransmitters like a bank account. MDMA doesn't magically create serotonin out of thin air. It simply spends almost all of your reserves all at once. When the drug wears off, your account is drastically overdrawn. Your brain is essentially completely bankrupt of the very chemicals it requires to regulate your mood, your sleep, and your appetite.
And the brain can't just snap its fingers and instantly refill those stores. It has to resynthesize that serotonin via tryptophan pathways. And honestly, that takes serious time. Here is the typical timeline of the crash. In the first 0 to 6 hours, the initial tiredness hits. Then, between 6 and 24 hours, the symptoms really start to intensify. The peak misery usually hits somewhere between 24 and 72 hours. This is that infamous Tuesday blues window where your energy just fluctuates wildly and your appetite completely vanishes. It then takes about 3 to 5 days just for the brain fog to lift and up to a full week for your brain chemistry to actually return to normal.
During that week-long window of chemical depletion, the physical and psychological symptoms can be absolutely brutal. Users frequently experience severe jaw clenching, that's known as bruxism, along with muscle aches and just extreme fatigue. And psychologically? Well, because your serotonin and dopamine are practically gone, individuals report feeling this profound emotional emptiness, heavy brain fog, and severe low mood. Plus, as the drug leaves the body, there's this nasty rebound effect. Because your receptors are suddenly starved of neurotransmitters, panic symptoms, anxiety, and irritability often spike quite dramatically.
Section 4. Long-term brain drain, the aftermath.
So sure, the brain does eventually recover its serotonin over a week or two. But what happens with repeated use? Well, now what's really interesting about this slide is that it shows visual evidence of long-term neurotoxicity. This is from a critical study by the National Institute on Drug Abuse involving monkeys given MDMA. The bright pink you see there, that represents the serotonin fibers in the cerebral cortex. On the far left, you've got your healthy control. But look at the middle image. That shows the severe, almost total destruction of those serotonin terminals just 2 weeks after MDMA exposure. But the most alarming part is that image on the far right. That is a monkey brain 7 years after MDMA use. 7 years. Notice how the serotonin network on the right is still visibly scarred. It is not fully returned to its normal, healthy density.
While a single occasional dose might allow the brain to eventually bounce back, repeated recreational abuse essentially forces the brain into a state of chronic depletion and potential structural damage. The science is clear. Repeated use significantly increases the risk of drug tolerance, dependence, chronic sleep problems, and long-term cognitive issues, like memory and attention difficulties. When the brain's serotonin system is repeatedly taxed like that, chronic depression and long-term mood dysregulation become very real and sometimes irreversible risks.
So, what does this all mean? Well, the crucial point we're left with is this massive biological paradox. On one hand, MDMA has an unparalleled ability to lower fear in the amygdala. It offers genuine, groundbreaking hope for severe PTSD trauma processing that traditional therapy just can't touch. Yet, on the other hand, it operates by mercilessly hijacking the brain's cellular machinery, which leads to profound chemical depletion and the risk of long-term neural scarring. So the ultimate question moving forward is this: can clinical science find a way to somehow isolate the incredible therapeutic benefits of MDMA without forcing the brain to pay such a heavy neurobiological price? It's a fascinating frontier of neuroscience for sure, and one we'll undoubtedly be watching very closely. Thank you so much for joining me on this explainer. Keep questioning, keep learning, and I'll see you in the next one.